Alright guys, so let's talk about how to find the mean absolute deviation. So the first thing we want to make sure we understand is what it is. And when I say mean absolute deviation, I'll refer to it as the MAD. And the MAD is a measure of variability. And in short, that's going to mean the spread of the data. So if you can remember that, that'll help you a lot. The spread of the data. Now here's how you actually do this process. It's a long process, bunch of steps, but very easy steps. So there's going to be 3 parts in this. The first part is your data, and that'll always be given to you, so you won't have to worry about finding that. The second piece is the mean. You'll need to find the mean, and to get that, you'll add all your numbers, and then you'll divide by the number of numbers. Next will be the absolute difference. Difference will mean subtract. Absolute value will mean always a positive answer. So we'll work on these 3 columns here. Now, your final step, once you have your absolute differences, is you're going to get the average of the absolute differences. So one more time, you'll add your numbers and then divide them by the number of numbers again. And that answer will be my MAD. So a lot of steps, but this is a pretty easy thing to follow. So I'll use this right here as a reference on your next problem. So here's an example. I want you to find the measure of variability for shoe sizes. So here are some of the sizes of some students in class. It's a mix between guys and girls, but there's just some of the shoe sizes. What I want you to do is find me the measure of variability, so find me the MAD. Now, I'll go ahead and show you this image again. Let's go ahead and put this in there, make it a little bit smaller though. So what I'm going to follow is these steps here. So this is what you need to think when you're solving these. I need you to think this process. So we start with our data, and then we'll go find our mean. So I'll add all the numbers. So all these here, I'm going to add them up. So I'll do 9 plus 9.5 plus 4 plus 12 plus 8 plus 5 plus 8.5. Now this is my total, then I'll divide by the number of numbers. So divided by, I had 1, 2, 3, 4, 5, 6, 7 numbers. And so I get 8. So the mean is 8. So I'll use that number here in the center, and you'll use that number all the way down. Now, I don't like rewriting the same number, so I normally just draw an arrow like that. Now, what I need you to do next is find the absolute difference. So you're going to subtract, but always a positive answer. So to get this number here, what's 9 minus 8? And that's pretty easy, right? That's just, that's 1. What's 9.5 minus 8? And you can use a calculator if you want. Shouldn't need to, but what's 9.5 minus 8? And I get 1.5. The next is 4 minus 8. So notice when I type it in, it gives me negative 4. But because I'm asking for absolute, even if it says negative, I'm only going to write it as a positive. So I'll do the same thing for the next. 12 minus 8, it's 4 again. 8 minus 8, that's 0. 5 minus 8, it's negative 3, but I'll write positive 3. So again, even though it says negative, you'll write it as a positive. And then last one, 8.5 minus 8. And I get 0.5. Now, what do I do with all of these numbers here? Well, the final step is going to be to find the average of the absolute differences. So I'm going to get all of these, and I'm going to add them and divide them by the number of numbers again. So let's add these numbers up. It's 1 plus 1.5 plus 4 plus 4 plus 0, which I don't really have to say, so plus 3, and then plus 0.5. And I get 14. So the total is going to be 14, and then divided by the number of numbers. So 1, 2, 3, 4, 5, 6, 7 numbers. And what's 14 divided by 7? 2. So my measure of variability here, or my MAD, is going to be 2. This is how you do the MAD. So let's try another example for practice. So I'll make this a little bit different. Which data set has a higher measure of variability? So which one has a higher MAD? So what we're looking at is pre-test scores and some post-test scores. What we want to do is we'll follow that same process as we did before. Notice how my data is already there. I just rewrote my data that was here onto this column. And let's go ahead and go find our mean. Now, I'm going to show you a method on the calculator to make things a little bit faster for us. So stat, edit. And what I'll do under list 1 is I'll type in my data. So 20, 50, 60, got 45, 85, and 70. And I strongly recommend that you go to double check that you type these in right. Because if you make a mistake, everything from this point forward will be wrong. All right, so what we want to do next is we're going to go to the home screen. And what we want to do is go to lists. So second, stat. And under math, you should notice option number 3, the mean. So you want to go ahead and find the mean of my data in list 1. So I'll press list 1. And here is my mean. My mean is 55. And I'll go ahead and use that number all the way down. All right, so my next step is to find the absolute differences. So you're going to start subtracting. So what's 20 minus 55, 50 minus 55, so on and so forth. But the way you would do this on the calculator is you're going to go to math, numbers, notice ABS, that means absolute value. And I'm going to find the absolute value of list 1 minus 55. So it's going to subtract them for me, and then the absolute value will keep them all positive. And so these are my answers. Now what you want to do is you want to save these numbers. And the way you save that is you use the store key. So STO is the store. You're going to store those on list 2. So now when I go into stat edit, under list 2 I have my numbers. So I'm going to go ahead and use that data for my T-chart over here, my table. So 35, 5, 5, 10, 30, and 15. Now what's your final step? Well, that's to find the average of your absolute differences. So add them all up and again divide by the number of numbers. Instead, on the calculator though, all I'll do is I'll go ahead and find the mean again, but this time of the data in list 2, because that's where I saved the numbers I need. And so in this case, my answer will be 16.6 repeating. And that's the MAD for the first part of this. Now again, I'm comparing these two MADs. So I'm not actually done yet until I compare this answer to this answer. So which of these has a higher measure of variability? Which one has a higher spread? So notice these scores, and now let's go check these scores. I'll go ahead and do this the regular method. I'll type it all in just so y'all can see the difference. And so my data's first, so 100, 95, 85, 75, 90, and 80. And what I'll do is I'll find the mean. And I'll do that the slightly slower method, that's fine though. 100 plus 95 plus 85 plus 75 plus 90 plus 80. So you add them all up and then divide by the number of numbers. So 1, 2, 3, 4, 5, 6 numbers. And so I get an 87.5. That'll be my mean. I'll use this number all the way down. And now we'll go and find our absolute difference. So we're going to subtract. Remember, everything is positive. So what's 100 minus 87.5? So we get 12.5. All right, next is 95 minus 87.5. So I'll use 7.5. All right, then we have 85 minus 87.5. And notice you get a negative 2.5, but I'm still going to write it as a positive 2.5. Now we have 75 minus 87.5. And I get 12.5. Make sure you write these as a positive. All right, next I have 90 minus 87.5. And then last one, 80 minus 87.5. And I'll write it as positive 7.5. All right, so now on to our final step. Add them all up and divide by a number of numbers. I know I have 6 numbers, so I'm going to divide by 6. But what do I get when I add all these up? Well, let's go type that in. So 12.5 plus 7.5 plus 2.5. Oh, I think what next is 12.5? Yeah, 12.5 plus 2.5, and then we have plus 7.5. Now here's my total. Remember, that's not my final answer. I still have to actually divide them by 6. So what's 45 divided by 6? And so my final answer would be 7.5. Well, actually, not my final, because now I can actually answer the question. Which of these two has a higher measure of variability? So which one has a higher mean absolute deviation? And between these two, my answer would be the pretest scores. So I guess I can box this in. Pretest scores are higher, have a higher measure of variability than the post-test. And you can actually tell if you look at your numbers, look at how far apart these are from each other. Super low scores, higher scores, medium scores, they're everywhere. But then if you look at the post-test scores, notice how these numbers are actually all closer to each other. So these aren't spread out as much as the pre-test are. So this is going to be how you guys find MAD.